This example has some kind of like a weird looking graph. And then it gives us three questions. Where's the limit defined? Where's the function continuous? Where's the function differentiable? Okay, so it's asking you to know those terms. Let me talk about them. What does it mean for a limit to be defined? Well, you remember how you could have a graph that goes like that and then goes away like that, whatever, and maybe an open dot there, solid dot there, and takes off. We would say right there, the limit is not defined. Why? Because for a limit to be defined, it must be the same from the left and the right. So like right here at one, from the left side, it's coming up there. From the right side, it's going down there. Oops, that's a problem. It's not the same at that point. And at three, it's a problem. From the left side of three, it's going down there. From the right side of three, it's going up there. So it's not going to be differentiable. Oh, sorry, I'm using the wrong word. It's not defined. The limit is not defined at 1 and 3, but everywhere else from 0 all the way to 4, from 0 all the way to 4, it's good. So that's why they said this answer right here. Now, I know that answer might seem a little mysterious. You might say, well, Mr. Heron, how's that any different than just saying 0 to 4? It goes all the way from 0 to 4. They just said it in three pieces. Yeah, they did specifically for the purpose of saying we're not including 1 and not including 3. Let me explain. If you put a parenthesis, say, and you go 1, 3, with parentheses. Do you remember that that does not include 1 or 3? Whereas if you put like say a bracket on the 1 and keep the parenthesis on the 3, now that includes the 1 but not the 3. Do you remember that brackets include the point and the parentheses don't? Right? Think about it this way. I just think a bracket has a straight edge. You're straight on the 1, smack on 1.0. But the parenthesis means is rounded, which means you're around the 3. But you're not straight on the 3. So in other words, you can include 2.999999, but not 3 right on the money, not 3.0. You're just around it. So the point is when they put a parenthesis next to a 1 and then a parenthesis next to 1 there, 1's not actually included in either interval. So 1 and also 3, it's the same thing with 3, parenthesis on the 3, parenthesis on 3. 1 and 3 are not included. When they write it that way, they specifically are saying no 1 and no 3 because at 1 and 3, the limit is not defined. There's parentheses next to the 1 and the 3. So the 1 and the 3 are not actually in any of those intervals. So this does go everywhere from 0 to 4, yes, but it specifically doesn't include 1 and doesn't include 3, which is what they're saying. Everything from 0 to 4, not including 1, not including 3. Now you might say, Mr. They should have included 0 and 4. Why didn't they include the endpoints, put a bracket there? Well, it's because they said down here, each interval treat the endpoints as not included. So they just wanted us to not bother with the endpoints. Parentheses just for the endpoints. All right, next question. Continuous. You know what that means. Just means you don't pick up your pen, right? You draw, 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 draw. Whoop, got to pick up my pen. So right there at 1, it wasn't continuous. And then same thing at 3, got to pick up my pen. Same answer, because at 1 and 3, it's not continuous. So that's all the numbers from 0 to 4, but not including 1. See, 1's not included and 3 is not included. Finally, differentiable. What does that mean? That means smooth. That's probably a new word for you, not jagged. It's a preview of the next chapter, coming attractions in chapter 3, where we're going to be studying derivatives. So to be differentiable, let me give an example. So if you have a graph that say goes like that and then like that, that right there, it's 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 jagged there. It's not smooth. So we say it's not differentiable. So to be differentiable is to be smooth. It's the highest level of niceness that we'd like functions to do. We'd rather the function kind of round it out there instead of doing like a weird jag thing. In math and science, it's just better for the ways we study things. We don't like jagged moves. So we say, where is it differentiable? Well, to be differentiable, to be smooth, It's got to be connected. So at 1, it's not even connected. And same thing at 3, it's not even connected. It's not even continuous. So how could it be smooth? So it's going to be the same answer. It's basically everywhere from 0 to 4, not including 1 and 3, because not even connected there. So it's certainly not smooth there. And so there we go.